Dear students, very good morning. Today we are going to discuss our sixth problem, that is we are given that if u equal to if u equal to 2xy, if u equal to 2xy, comma v equal to x square minus y square, x square minus y square, and x equal to r cos theta, x equal to r cos theta, comma y equal to r sin theta, then we want to evaluate dou of u comma v divided by r comma theta, dou of u comma v divided by dou of u comma v divided by dou of r comma theta. We want to evaluate dou of u comma v divided by dou of r comma theta without actual substitution, without actual substitution. So now so this formula resembles the cyclic form of Jacobian, because here we can use second property, because here u and v are functions of x and y, whereas x and r are functions of r and theta. See, I shall write solution here. Solution. So here u is the function of x and y. U is a function of, see, u is the function of x and y, and both x and y are functions of r and theta. These are functions of r and theta. In the same way, we are having, so if we want to find total derivative, means we have to make use of this formula. We want to make use of this formula. In the same way, here we will have v instead of u. We will have v also. So if so, then we can find dou u by dou r equal to, we can find dou u by dou r, we can find dou u by dou r and dou u by dou theta, then dou v by dou r, dou v by dou r, and dou v by dou theta, dou v by dou theta. From the formula, from this diagram we can find this formula. If we do so, it is called actual substitution. 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 So we are not supposed to do like this. We are not supposed to do like this. Here we have to make use of the formula. Here we have to make use of the formula of cyclic. Here we have to make use of the formula of cyclic property of Jacobian. Okay, cyclic property of Jacobian. So it cannot be used if we find all these things similar to total derivative means, then the mark will not be awarded. Since they want us to find dou u by dou v divided by dou r by dou theta without actual substitution, means we are not supposed to apply these formulas here. Okay, first thing. Second thing is where we can apply this. So for verification purpose we can use this. For verification of our answer we can use this. So finally I will verify the problem if possible. Okay, if time permits, then I will explain how to verify the result by using the formula. Okay, so I shall copy this. I shall cut this. Okay, now I hope you are understanding the problem very little much. So we shall start our problem. So we are given the value of u, value of v. Now we want to find dou of u comma v, divided by dou of r comma theta, dou of u comma v divided by dou of r comma theta. It since we have to check here, u equal to function of x comma y. Okay, function of x comma y. In the same way v is also function of x and y. Okay, function of x and y. Okay, function of x and y, but x is the function of r comma theta. X is the function of phi of r comma theta. R comma theta. Okay, in the same way y also. Y is also a function of r comma theta. So here we can take gamma of r comma theta. Okay, so we can write dou u by, we can write this by means of dou of u comma v. Both these are functions of u and v are functions of x and y. So we can differentiate u and v with respect to x and y. So dou u of dou u comma v divided by dou x comma y. Okay, dou x comma y and into, and x and y are functions of r and theta. So x and y can be differentiated positive with respect to r and theta. So dou of x comma y with respect to r and theta. So what will be easy? Applying this property will be very easy. So actual substitution will be very tough. Instead of that, we can directly make use of this property. That is the advantage of property. As I have already told you, the advantage of property is that we can easily solve the problem. Okay, so dou of r comma theta. Okay, now for this we will have the Jacobian. So here I shall simply write it as j capital J equal to for my reference only J U comma V into J X comma Y. Okay, J X comma Y for your reference only. Okay, so we have to find J U V with respect to XY and J X with respect to R theta, and finally we will get J, which is J of U comma V with respect to R comma theta. It is also J U V, so it may create you some confusion. If you can use some other notation, you can use those notations also, otherwise it is not necessary. If required means you can use these alternative notations for easy reference. Okay, but you have to keep in mind the reference you are using. Okay, so without reference also we can write directly here, but you have to write the full term each time, otherwise you can simply put J. Okay, so here I am writing Jacobian of dou U by dou X, and dou U divided by dou Y, dou U by dou X, dou U by dou Y. Here dou V by dou X, dou V by dou X, and here dou V divided by dou Y. Okay, into dou X by dou R and dou X divided by dou theta. Here dou Y divided by dou R, and here dou Y divided by dou theta. Okay, so we are having these two things now. Then here we want to find dou U by dou X, all the terms today. Here we want to find all the terms. Okay, so first of all we are having U as the function of X and Y. Okay, see, U is the function of X and Y. If I differentiate it with respect to X, X will become 1, so I get 2Y. If I differentiate it with respect to Y, Y will become 1, so I get 2X. So 2Y and 2X are the results, 2Y and 2X. Okay, so first term is with respect to X I am getting 2Y, and here it is 2X, and dou V. So when I differentiate this V with respect to X, I get 2X, and with respect to Y I get minus 2Y. So 2X minus 2Y. Here it is 2X and minus 2Y. X and minus 2Y. Okay, and now on differentiating X with respect to R, I get cos theta, and differentiating Y with respect to R, I will get sin theta. So X differentiation of X with respect to R is cos theta and Y is sin theta. So x with respect to r is cos theta, and y with respect to r is sin theta, okay. Now x with respect to theta, y with respect to theta. Okay, x with respect to theta means, so r is constant and differentiating cos theta we will get minus sin theta, so it is minus r sin theta, and y is r cos theta. So minus r sin theta and r cos theta, minus r sin theta minus r sin theta and r cos theta, minus r sin theta into r cos theta, or cos theta, okay. Now we have to take the determinant and we have to multiply. So here we are having 2 into minus 2 is minus 4, so minus 4 y square, then minus 4x square, okay, minus 4y square into minus 4x square into, here we are having r cos square theta, then plus r sin square theta. The determinant value is r sin square theta, okay, r sin square theta, okay. Now we can take this minus 4 commonly outside, so we get x square plus y square, okay, x square plus y square, into, I can take r here commonly outside, and we will get cos square theta plus sin square theta, cos square theta plus sin square theta, cos square theta plus sin square theta, sin square theta. So what is x square plus y square? Now we have to find what is this x square plus y square. We have given x equal to r cos theta and y is equal to r sin theta. So it is r square cos theta plus r square sin square theta. Am I right? So it is minus 4 into r square, okay, cos square theta plus r square sin square theta, into this term, or cos square theta plus sin square theta is 1, okay. So here we can take r square commonly outside. If we take r square commonly outside, we get again cos square theta plus sin square theta, so it will become 1. So already we are having minus r outside, 1 r outside, so we are having minus 4 r square of 1 into r, that is equal to minus 4r cube, minus 4r cube, okay. Now we shall write the result separately. We shall write the result separately. Okay, we shall write a result. Dou u by dou v of r comma theta equal to dou u comma v divided by dou r comma theta equal to equal to minus 4r cube. Okay, so this is our result. Okay, now as I have already mentioned, we can do verification. How to do the verification? Here we are having dou u comma v divided by dou r comma theta. So I shall paste. Oh, so sorry, I have copied something else, so already copied thing has gone. So okay, we shall write here separately verification. How to verify whether our answer is correct or not. Okay, actually verification will take much time, because the property here we have used a property, so it will be easy than the actual substitution. So here we are using verification. So what we have asked to find? We have asked to find dou u comma v divided by dou r comma theta. Dou u comma v into dou r comma theta. Dou u comma v divided by dou r comma theta equal to we can write it as dou u, okay, dou u by dou r, then dou u divided by dou theta, and here dou v divided by dou r, and here we are having dou v divided by dou theta. Okay, dou u by dou r, dou u by dou theta, dou u by dou r into dou u by dou theta. We want to find those things. Okay, now for finding those things we have to make use of the formulas for total derivatives. Okay, now we are having u is the function of x and y. Okay, in the question we are having u is the function of x and y. So we have to draw this diagram, and both x and y are functions of r and theta. Okay, r and theta. Okay, r and theta. In the same way we are having it for v also. In the same way we are having it for v also. So I shall copy this and I shall paste it very closer to this. Okay, so but instead of u we will have v. Instead of u we will have v. Instead of u we will have v here. Okay, now so we can reach u by means of u to x. We can reach r from u. We can reach r from u by means of x and y. Okay, by means of x and y. Okay, x and y. So here it is composite functions of two variables. Okay, here it is composite function of two variables. Okay, so we have only going to use the partial derivatives in the formulas. We are going to use only partial derivatives. We are going to use only the partial derivatives in the formula. Okay, so this understanding a diagram is very important. How to draw diagram for each problem is very important. Okay, now here we will have, since use function of two variables, we have to use dou u divided by dou x, dou u divided by dou x. Here we will have dou u divided by dou y, and here we will have dou x by dou r, okay, and it is x, dou x by dou r, and here we will have dou y by dou r, dou y divided by dou r, and here we will have dou x by dou theta, and here we will have dou y divided by dou theta. Okay, and here it is dou v by dou x. It is, instead of u will have dou v by dou x, and here it is dou v by dou y, dou v by dou y. Here it is dou x by dou r, dou x by, is correct, dou x by dou r. Here it is dou y by dou r. So dou y by dou r, dou r. Okay, and it is dou x by dou theta, dou x by dou theta. It is dou y by dou theta. Okay, dou y by dou theta. Okay, now we have written the diagrammatic representation of this formula. Now for dou u by dou r, now for dou u by dou r, we will have the formula, this dou u by dou r equal to, so how to reach r from u, dou u by dou x into dou x by dou r plus dou u by dou y into dou y by dou r. Okay, so here dou u by dou x, dou u by dou x into, okay, dou u by dou x into dou x divided by dou r plus dou u divided by dou y into dou y divided by dou r. So this is our first step, that is the first element of our first row. Okay, so the second element of our first row, control plus C, control plus V. So we will have our second term as dou u by dou x into with respect to theta. So it will become dou x by dou theta. Okay, dou x by dou theta. Then here also dou x by dou y by dou theta. Also it will become dou theta. Okay, dou theta, and also it is dou theta. Okay, now the second row elements are given by given by dou u. Instead of u we will have v. So and the other things are common. Okay, it is v. The things are common. Okay, so here we will have v everywhere. Here we will have v, and here also we will have v, and here also we will have v, and finally we will have v here also. Okay, v here also. Now we have to substitute the values of dou u by dou x and dou x by dou r plus dou u by dou y into dou y by dou r, everything here, and finally we have to take the determinant. So for my easy reference, I shall copy and paste the value of x and y. Copy the value of x and y below. Okay, because for each time I have to come up, it is very tough. So I am copying all the values. here. I'm copying all the values here. Okay, I'm copying. Okay, then okay. Okay, then finally so I am copying all the values. I'm copying all these values and paste it here. Okay, so now we have to write here. Dou u by dou x. So dou u by dou x is 2y. Dou u by dou x is 2y into dou x by dou r. Dou x by dou r is cos theta. 2y cos theta. Okay, 2y cos theta plus dou u by dou y. Dou u by dou y means it is 2x. It is 2x, and dou y by dou r means it is sin theta. Dou y by dou r means it is sin theta. So 2x sin theta. It is sin theta. Okay, then dou y by dou x. Dou y by dou x is common, so we shall copy this. Okay, we shall copy 2u cos theta. Now we have to copy the complete thing. Okay, copy complete thing. Control plus C, control plus V. I shall copy everything here, but only the term what will get cancelled. Dou x by dou theta means it is okay. Dou v by dou x is 2y, but dou x by dou theta means we will have something different here, and here also dou v by dou y equal to okay, but here it will be different. Dou y by dou theta will be different. Okay, so what will be dou x by dou theta? So x by theta, dou x by dou theta means you have to differentiate with respect to theta. So r is constant, so we get minus r sin theta. So we get minus r sin theta. I am writing minus in the front and r sin theta here. R sin theta, r sin theta. Okay, plus 2x into dou y by dou theta means it is r cos theta. R cos theta. Okay, it is r cos theta. Now we have to find dou v by dou x and dou x by, so we have to find all these things. Now what is v? So dou x by dou r will be common and dou y by dou r will be common. Okay, so we shall copy the numerator first row as it is. Okay, we shall copy the first row. Okay, because only dou v by dou x and dou v by dou y alone will get changed. Only dou v by dou x and dou v by dou y alone will get changed. So we shall copy the rest of the things as it is. Okay, so we get control plus c, control plus v, we get everything pasted here. Now we have to check whether what are terms going to change. First, dou v by dou x will definitely get changed. Dou v by dou x will definitely change. Okay, dou v by dou x will definitely change, and in the same way dou v by dou y also change. Dou v by dou y will also change, and here also dou v by dou x will change. Okay, dou x by dou theta is minus r sin theta, so this minus will be there, no problem, and dou v by dou y will change. Dou v by dou y is 2x. Okay, now what is dou v by dou x and dou v by dou y? Okay, dou v by dou x means it will become 2x. So dou v by dou x is 2x, dou v by dou x is 2x, and so I am writing 2x here also into 2x. Okay, and dou v by dou y is minus 2y, so it is minus 2y. So I am putting minus here. I am deleting this plus, and I am putting deleting this plus as well as this plus, and we are having minus 2y. Okay, minus 2y. Okay, minus 2y. Here also minus 2y. Now we have to take the determinant. So since here minus is common, we can take the minus outside, but anyway we can, since we are going to multiply, we can simply write all the terms together. So first term into first term, and first term into second term, then second term into first term, second term into second term. Okay, first term with the first term and second term, and second term with first term and second term. Okay, that is how we are going to do this multiplication. So minus 2xy r cos theta, the first term will be, the determinant will be minus 2 into 2, it will be 4. So minus 4 Okay, but instead of that we can do one thing that will be very easy. Okay, that will be very easy. Before proceeding to the determinant, we can substitute the values of cos theta and substitute values of x and y. So we can substitute the value of x and y. So here we will have to x equal to r cos theta, y equal to r sin theta. Okay, y equal to r sin theta. So 2 into r cos theta sin theta. Okay, 2 I think okay, I think no terms will get cancelled. I am substituting with respect to y and x. No term will get cancelled. So better we shall first cancel x and y and then we shall substitute the rest of things. So we shall first take determinant. Okay, because if suppose if I substitute value of y and these two cos theta will get cancelled, means no problem, we can substitute and then we can take determinant, but here nothing will get cancelled. So we shall take the determinant first. We shall take the determinant first. So we are having 2 into 2 is minus 4 x y minus 4 xy or cos theta sin theta minus 4 xy or cos theta sin theta. Okay, so we have to check whether we have miscellaneous term minus 4 xy or cos theta sin theta. So now terms are mixed. First term with the first term. Okay, now first term with second term we get minus 4 y square minus 4 y square or cos square theta then. So now we have completed first term with respect to with first term and first term with second term. Now we have to multiply the second term with first term and second term with second term. So we will get minus 2. So 2 into 2 will become 4 x square or 4x square or sin square theta. So sin square theta and second term with second term minus 4xy minus 4xy into minus 4xy into r sin theta cos theta sin theta okay, sin theta. Now the multiplication of trace, that is main diagonal elements, are over. Okay, are over minus. So this into this is over. Now we have to multiply this into this. So there we will have one minus in the formula. There we will have one minus in the formula itself. So I am putting the minus here into this 2x. Okay, here first term with first term. So we'll get 2 into 2 4. So that is 4 xy. What 4? It is minus 4 xy or cos theta sin theta, cos theta sin theta, cos theta sin theta. First term with first term, and first term with second term you will get plus 4 x square or cos square theta, cos square theta. Okay, 4x square or cos square theta. Now first term will first and first term will second are over. Now minus the second term with first term, so it is minus into minus will become plus. Okay, plus 4 second term with first term plus 4 y square or sin square theta, okay, sin square theta. Then second term with second term minus 4xy or cos theta sin theta, cos theta sin theta. Okay, sin theta okay. Now we have to cancel some terms. How to cancel? Since we are having some terms in the first half minus second half, so since this minus is multiplying the second half of terms, so the terms with the same signs to the first half when multiplying with the negative again will differ only with this sign, so the terms which are looking same will get cancelled after multiplying this with minus. So hence here also 4xy or cos theta sin theta, here also minus 4xy or cos theta sin theta. I am just striking it out, okay, because it will become the second half will become plus, and here after multiplying, since these two are 4y square or cos square theta and minus 4y square or sin square theta are there, these two terms this term will not get cancelled, this term will be there, and I think okay before that we shall, so these two we shall check, these two minus 4xy or cos theta sin theta, and these two terms also will get cancelled since they are having same sign before the second half is getting multiplied with the minus. So after multiplying it with minus, the sign will change, so it will become different. Now we are having only these terms. Now we are having only these terms, okay, only these 4 terms. Now the minus will come here also and here also, so it will become minus 4x square or cos square theta, and it will become minus 4y square or sin square theta. Okay, so we have to arrange the terms in such a way that we will get minus 4. Okay, minus 4. What is common? We can take commonly y square r. We shall take y square r commonly outside. So minus 4y square r into cos square theta, and here also there is minus outside, so sin square theta, cos square theta plus sin square theta, cos square theta plus plus sin square theta. Okay, sin square theta. Okay, then again we are having minus here, so we shall take minus outside. So minus 4, we shall take x square r common outside. X square r, if I take x square r common outside, again we will have cos square theta plus sin square theta. So I shall copy this and paste it here. Okay, so control plus C, control plus V, minus 4 x square r into cos square theta into sin square theta. Okay, okay, now we have to use the value of cos square theta plus sin square theta, that is 1. So we will have minus 4, we shall take r also commonly outside. So this is 1, so we are having minus 4 r of x square plus y square, x square plus y square. We will have this minus 4 r of x square plus y square, and that is equal to, since x equal r cos theta, y equal r sin theta, we will have minus 4 r into r square can be taken commonly outside, r square into cos square theta plus sin square theta. Okay, r square cos square theta plus r square sin square theta. So we get, this will become 1, and so our result is minus 4 r cube, minus 4 r cube. So which is our result. So what is our question? Our question is, we have to find dou of u comma v, with respect to dou of r comma theta, equal to minus 4 r cube, okay, minus 4r cube. This is our result. So we shall check whether so this was done by actual substitution, and the previous result was obtained by property, that is chain rule property of Jacobian. So in the above result we are having minus 4r cube, and here also we are having minus 4r cube. Hence our results are same and they are thus verified. If in the examination, if they have asked you to verify, means you have to verify, otherwise you are not required to verify, just to solve the problem by using properties. If they have mentioned without actual substitution, means you have to use the chain rule property. If you solve it directly with substitution, means the mark will not be awarded. Okay, we have to be very conscious about that. So I hope you all understood the problem, and this problem is very important. In this problem we have seen how to apply chain rule property of Jacobian to solve the transformation of variables to the function of dou u comma v divided by dou r comma theta, and we have verified it using direct substitution. So I hope you all enjoyed the video. In next class we shall meet with some other problem or some other topic. Thank you all for watching this video. Thank you all once again.